Imagine a spaceship, sleek, silent, and pulsing with energy, poised on the edge of reality. The countdown begins, not for a moon launch, not for Mars, but for something far more ambitious. You're about to break the ultimate speed limit of the universe, the speed of light. But what happens when you do? What does faster than light travel really mean for physics, for space, for time itself? Let's talk about it. Light speed isn't just fast, it's the cosmic speed limit, roughly 299,792 kilometers per second, or about 186,000 miles per second. That's fast enough to circle the Earth more than 7 times in 1 second. In the early 20th century, Einstein's theory of relativity told us something weird. Nothing with mass can reach the speed of light, much less exceed it. The faster you go, the more energy it takes. At light speed, it would take infinite energy, and we don't have that. So the idea of faster than light, or FTL travel, seems like pure science fiction. But what if it weren't? Let's say somehow you figured it out. Maybe you built a warp drive, or opened a wormhole, or discovered a hidden loophole in physics. Suddenly, you're zipping through the galaxy faster than light. What happens? First, time gets weird. According to relativity, as you approach light speed, time for you slows down compared to someone standing still. If you could go faster than light, it's not just time slowing, it's time flipping. From the perspective of an outside observer, you might appear to be traveling backwards in time. Let's repeat that. Going faster than light might let you go back in time. Suddenly, the universe is no longer just about space. It's about causality. Cause and effect. If you can arrive before you left, you break the logical structure of reality. You could send a message to the past, or meet yourself before your journey began. That's the realm of time paradoxes, like the famous grandfather paradox. If you go back in time and prevent your own existence, what happens then? Second, space collapses in on itself. Imagine Alpha Centauri, the closest star system to us, 4.3 light years away. At light speed, it would take you 4.3 years to get there. But at 10 times the speed of light, you can make the trip in just a few months. At 100 times light speed, a couple of weeks. Eventually, with fast enough FTL travel, the entire galaxy becomes as accessible as crossing the street. That's not just speed. That's changing the scale of the universe. Distances that once took generations become afternoon errands. But hold on, is there any way this could actually work? Maybe. There are some hypothetical concepts, very hypothetical, that might allow faster than light travel without breaking physics. One is the Alcubierre drive, a theoretical warp drive. It doesn't move you faster than light through space. Instead, it contracts space in front of you and expands it behind you. You ride a kind of bubble through space-time. In theory, this doesn't violate Einstein's equations, but there's a catch. It requires negative energy or exotic matter, something we don't even know exists. Another idea? Wormholes. These are shortcuts through space-time, like folding a piece of paper and punching a hole through it. If you could keep one open, you might travel between distant points faster than light would in normal space. But wormholes have their own problems. They collapse instantly unless stabilized by negative energy. And even then, the risks of time loops and paradoxes explode. So, let's be real. FTL travel probably won't be possible in the way science fiction shows it. But that doesn't mean we're stuck. Relativity still allows for time dilation. If you travel close to the speed of light, say 99.9999%, time slows down for you. You could travel hundreds or thousands of light years while only aging a few years yourself. To you, it would feel like FTL travel, even if it isn't. You're not breaking physics. You're bending it to the edge. But let's ask a deeper question. Should we even want faster than light travel? Sure, the idea of exploring the galaxy, meeting alien civilizations, or starting colonies on new worlds is exciting. But with that comes power, danger, and unpredictability. How do you enforce laws in a universe where people can arrive before they left? What if someone sends a weapon back in time? What if two civilizations meet and their timelines disagree? The consequences of FTL travel might be stranger and more dangerous than anything we've imagined. Still, the dream persists. Faster than light travel isn't just about speed. It's about freedom. It's about breaking boundaries. It's the next great adventure, the ultimate rebellion against limits. And while the laws of physics may say no today, who knows what tomorrow might bring? Maybe the speed of light isn't the end of the road. Maybe it's just the beginning. If you enjoyed this video, hit like and subscribe. See you.